So in the first lecture, we saw how to introduce lists into our pseudocode notation. So we had the square bracket notation to write a sequence of values, and we had the for each loop which allowed us to systematically examine the values in a list. So now let's look at an example. So the example that we're going to look at is the one where we are trying to identify the top students in all subjects. So we would say that a student is a top student across all subjects, say if that student has within the top 3 marks in each of them. So in physics and in maths and in chemistry, the student has scored among the top 3 marks. So we had already seen quite a while back when we discussed procedures, how to write a procedure for the top 3 marks in a subject. So we keep track of this maximum, second maximum and third maximum, and then for each row in the table or for each card in our data set, we check the marks in this subject for that card, and if that card, so we have basically 3 possibilities. So we have max, second max and third max, right? So the new value that we see could be either bigger than max, in which case everything gets shifted by 1, or it could be between max and second max, in which case only the second max gets shifted, or it could be between second and third max, in which case the third max gets replaced by this card. So those are these 3 if conditions. So either it is bigger than the max, in which case you shift the max down to second max and the second max down to third max and replace the max by this one, or if it is between max and second max, then you replace the third by the current second and make this the new second. Or if it is between second and third, then we leave max and second max as they are and we replace the third max by this. So what this does is it calculates the third highest, second highest and highest marks in each subject, and finally it returns what we are really interested in is this cutoff. So it returns a single value which is the third highest mark in that subject, and this is parameterized by the subject name. So if we call it with physics, we get the physics marks, call it with mathematics, we get the mathematics marks, and so on. So now that we have this procedure, what we know is that the cutoff is given by the procedure, but we don't know how many students are there above this cutoff, right? So any student who has got more than or equal to the third highest mark is considered to be a top student in that subject. So this is where lists come in. So we will take, for each subject, we will take the list of students who are toppers in that subject by querying this procedure, and then we will have to check whether there is a single student or how many students actually appear across all these 3 lists. So the first step is to identify what the cutoff criterion is. So this we get, as we said, by calling the procedure that we just saw. So we look at this top 3 marks and we call it with mathematics, physics and chemistry, and we get the corresponding values of the cutoffs for maths, physics and chemistry. Now we want to construct these lists of students who are above the cutoffs in all these 3 subjects. So we have 3 lists, one for maths, one for physics, one for chemistry, and we initialize each of them to be empty to begin with. Now we do one pass over the table again, right? Because we don't have these marks anywhere except in the table. So we had done one pass in the table each time when we constructed these top 3 marks, but now we have to look at each mark and decide whether that student qualifies as a top student. So we look at each row in the table, then if the maths mark is above the maths cutoff, then we will put this particular card into the maths list. Similarly, if the physics mark is above the physics cutoff, we will put it into the physics list. And thirdly, if it is above the chemistry cutoff, we will put it in the chemistry. So for each row that we process, we check each of these 3 criteria, and in one shot, by processing that row in one shot, we know whether to add it to maths, physics and chemistry or not. So at the end of this, we have these 3 lists, right? We have the physics, maths and chemistry, and now we want to find out if some element is common to all 3. Now in our first lecture, we already looked at this idea of a nested loop to find out if some element is common to 2 lists. Remember that we looked at the students who were born in May and were from Chennai. So we said if we have a list of students born in May and a list of students who are from Chennai, by doing a nested for each, we can check whether a sequence number appears in both lists. So we can do the same thing for maths and physics now. So we want to find out all common elements between maths, physics and chemistry. So if a student is a topper in maths, physics and chemistry, obviously the student is also a topper in just maths and physics. So the first step is to just find out those who have topped maths and physics both, because unless they have topped both of maths and physics, they are not candidates to be a topper overall. So we first do this exact same nested loop that we did earlier. So we start with this maths physics list set to be empty, and now for every student who we have put in the maths list, we check for every student who we have put in the physics list if they are the same or not, and if we find that there is an X in the maths list, which is equal to a y in the physics list, then we add that x to the maths physics list. So maths physics list, which we have created now, is a list of toppers in both maths and physics. And now we take this list, so we now know those students who are toppers in 2 subjects, and we want to check if they are also toppers in chemistry. So now we do a nested iteration between maths physics list and chemistry list. So maths physics list is the list we just created, chemistry list is the list that we got by examining the cutoff marks, and again by doing this nested iteration. So in 2 nested iterations, basically we have extracted the toppers across all 3 subjects. So this example illustrates that we can use lists to collect items that share some property. So in the first lecture, we looked at people who were born in a month or who came from a particular place. Here we are looking at people who have scored above a certain mark in a subject. And then nested iteration repeatedly comes up as a useful way, using this for each operator, to examine pairs of elements across 2 lists to identify those which are same or those which are different. For example, you can also use the same thing and say, is there an x in the first list which is not present in the second list? So by minorly modifying the nested loop, you can also find out elements which are only in one list but not in the other, but we were interested in finding out elements which were in both lists. So you can do a variety of things to compare elements in lists using nested loops. Then we also saw that if you wanted to do this nested iteration for more than 2 lists, of course in principle you can do it for 3 lists at a time. You can take up every x, every y, every z and check if x is equal to y is equal to z and then put it in. But we can also do it more simply by doing a sequence of pairwise iterations. So we saw it for 3. So for example, supposing you had 4. So supposing you wanted to find out elements which are in list 1, list 2, list 3 and list 4. Now we could do it the way we did before, which is that you could take, for instance, those which are in list 1 and list 2. So you will get a pair like this. Then we can take this and get those which are in list 1, list 2 and list 3. And then we could do this and get to list 1, 2, 3 and 4, right. So this is one way to extend what we did. Supposing we had a 4th subject, biology, then we could have started with maths and physics, then taken those who have got top marks in both maths and physics and then compared them with chemistry to find out if it's maths, physics and chemistry, and finally take maths, physics and chemistry and also add biology and find out all 4 subjects. So this is one way to do it. A different way to do it is to group them like this. So you first take list 1 and list 2, right, and now you separately take list 3 and list 4. So now you have people who are toppers in the first 2 lists, people who are toppers in the last 2 lists, and then you can merge the first 2 lists and the last 2 list toppers to get 4, right. So in general, if I have, for example, 8, this would be now interesting because, for instance, I can first get this one. So each pair I can do, then I can get this pair, and then finally I can do this pair, right. So there are many different ways to do it, but essentially you can always break it down into a pairwise calculation if you want to. So that summarizes this example.